Very good evening to all. This is Mahendra presenting you the Unix shell programming, and there are three contents for today. Its first one is Unix operating system components, second thing is silent features of Unix, and third is system architecture. Let's move on with the Unix operating system component. The first one is the kernel. The Unix kernel is the center core of the operating system. It provides an interface to the hardware device as well as to the process, memory, and input-output management. The kernel manages requests from user via system calls that switches the process from user space to kernel space. And some of the functions of the kernel is like it communicates directly with the hardware, and it manages system memory, and it handles the file store and communication in response to system calls also. And the second thing is the shell. A shell is a command line interpreter, or the shell that provides a command line user interface for a Unix like operating system. The shell is both an interactive command language and a scripting language, and it is used by the operating system to control the execution of the system using a shell script. And the shell acts as an interface between the user and the kernel. Even though there are only one kernel running on the system, there could be several shells in action, one for each user who is logged in. And the third is system calls. System calls in Unix are used for file system control, process control, and interprocess communication, etc. Access to the Unix kernel is only available through this system call. Generally, system calls are similar to function calls. The only difference is that they remove the control from the user process. Unix is written in C, though there are thousands of commands in the system. They all use a handful of functions called system call to communicate with the kernel. All versions of Unix use the same system calls. And let's move to the another topic. It's called silent features of Unix. The first one is multi-user system. See, multi-user system is like the name itself is suggests Unix provides multiple programs to run and complete for the attention of the CPU. This happens in two ways. One is multiple user running multiple jobs, and single user running multiple jobs. And second thing is multitasking system. The important thing here is that one job can be seen running in the foreground, the rest all seem to run in the background. Users can switch between them, terminate and suspend any of the job. Like it's like very simple. A single user can be running a multiple tasks concurrently. It is usually for a user to edit a file, print another one on printer, send email to a friend, and browse the websites all without leaving any of the application. The kernel is designed to handle a user's multiple job. And the third thing is pattern matching. Unix provides a very sophisticated pattern matching features to metachar, that is a special character used by the system to match a number of file name. There are several other meta character in Unix. Apart from the known as a meta character, there are several other special character used in Unix system. Unix features elaborate pattern matching schemes that use several character from this meta character set. And the programming facility, the Unix provides a shell which is also programming language designed for programmer, not for casual end users. It has all the control structure, loops, and variable required for the programming purpose. These features are used to design the shell script, and many functions of the system can be controlled and managed by the shell script. The Unix shell is also a programming language. It was designed for a programmer and not for the any casual end user. And the next topic is called as Unix system architecture. In this Unix system architecture, we'll be knowing about system calls, file subsystem, process subsystem, hardware control. The first one is file subsystem. And Unix operating system will be divided into two layer. One is user, kernel, and hardware, sorry, three layer. And the first one is like the system call and library interface represent the border between user program and the kernel. There are two sets of system calls. One set interacts with the file subsystem, and another set interact with the process subsystem. The first one is the file subsystem, manages files, allocating file space, administration, taming free space, controlling access to files, and retrieving data for users. Process interact with the file subsystem via specific set of system call. In process subsystem is responsible for process synchronization, inter-process communication, memory management, and process scheduling. The file subsystem and process control subsystem interact when loading a file into memory for execution. System calls used for controlling process are fork, exec, exit and wait, and etc. And finally, hardware control. Hardware control is responsible for handling interrupts and for communicating with the machine. Devices such as disk or terminal may interrupt the CPU while a process is executing. Kernel may resume execution after processing the interrupt. Interrupts are serviced by special function in the kernel. And thank you.